So like my topic for the GSOC project was credit risk assessment. So about the topic, the primary objective was to develop a predictive model using which we can look to estimate interest repaid and nominal interest rates which financial institutes could look to charge. And for the significance of the project involved risk management, pricing strategy, and regulatory compliance. So the problems that motivated us to have this project was inaccurate risk pricing. So like the traditional methods can't give you a precise assessment for what we could look to charge to an individual borrower. High default rates, capital adequacy. So like financial institutions are required to adhere to certain regulations and maintain some certain limit of credit, and lack of personalization. So the problems that we had in our previous iterations were inefficient data size, lack of EDA, there was no feature engineering involved, there were some certain labeling issues as well. There were data leakage issues where we were using features that which we would not have had at our present scenario. And the setup required, and we had to set up the whole project locally. So like I'll give a brief review of the current work. So like feature, like removing columns, removing the unique column values, merging the data set and sorting the merged data sets and was a data preparation part. So basically we had multiple data sets that we had to combine and take out the unique values to create a data set. Then we had removing the columns, encoding the data sets, and removal of features that had high correlation. So the thing was, like, if you have a large number of large number of columns, large number of rows with missing values, you just simply can't use imputation techniques and replace them, because that would give you a lot of bias. So to prevent that, I had to eventually remove the columns. And then as you had a large data set that was around 6 GB, so I had to further reduce the features. For that, I used chi-square and p-value and over feature scores and recursive feature elimination. Now, after that, I developed our interface for our credit scorecard as well. So the predict feature, you can choose the feature which you wish to predict. You can select the model. So we have 3 models: decision tree, random forest, and linear regression for the regression problem, and logistic regression for the classification problem. So the specific values, if you don't have any values, you can use the fill with specific value, that it would fill it with the average value. You can select the features from the list of features, and then you can put in the values yourself and submit it. So the project is live over here. So the certain additions that I made to the front end features to make it easy for the users to use it was for the sake of applying the models, you had to one hot encode the features, but you can't expect the user to put in the value as 0 or 1. So eventually I had to reverse it back and use normal encoding. Now for dates, the thing was, if you're using certain models that are not tree based, you will have to have put numerical values. But so that the user can put in string values, I had built a pipeline that converts the strings again to a date and a comma date the whole data accordingly. So just in case the user doesn't have a mixed value, it's not that he cannot use a dataset, it will fill it automatically with the average value. The user has the option to choose 3 models. He can use all 3 of them and choose the best one accordingly. So thank you. That's all from my side.